So now in this video, we're going to look at one of the ways you can take a voltage that you want to apply to a load without disrupting the voltage of what is setting it. So I have here a Zener diode version, a trim pot, and a light dependent resistor version right there. So you can see that the trim pot, you just put a power supply across it. If it's 5 volts across it, this is a 10 kilo ohm trim pot, by the way, you can turn the knob and get from 0 to 5 volts right there. And at 5 volts, you'll actually get the full 5 volts because there'll be no resistance. But anywhere lower, there'll be resistance along that path there, and it will be limited to how much current it can provide to hold the voltage. And a light dependent resistor, it's like 2 fixed resistors, but one of them is a light dependent resistor where its resistance changes based on the light on it. So tons of light on it, you'll get directly to the negative rail for the most part. So you want to make sure you have enough current to protect the light dependent resistor. If it gets enough resistance, I mean, to protect the light dependent resistor from high current if it gets to about 0. But otherwise, the percentage of the resistance will determine the voltage out. So if it's dark enough, it'll be millions of ohms of resistance. You'll have basically 5 volts. But again, it's going through a 1 kilo ohm resistor, so it'll limit current. And then the Zener diode, it's the Zener voltage. And I should have used a lower value resistor there. But you got to make sure that you don't pass too much current through the Zener. But you have to be able to provide enough current for whatever load, if you're doing a load directly. And so a better option is just to use the transistor as an emitter follower, or you could call it a common collector. Those are the 2 names for it. And there's other ways. There's actually better ways to get a voltage, but this is pretty simple, and most people have NPN bipolar junction transistors. And so the other options, you may not have the components you need. So in any case, I'm using the 2N3904 in this video right here. The flat sides here. So we got the emitter to the left, base in the middle, and collector to the right. If I swivel it this way, collector's on top, base is still in the middle, and then the emitter is at the bottom. So the emitter will go to that resistor, collector will go to that yellow jumper up there, because the emitter follower, common collector, you put the collector directly to the positive rail. You don't want to limit current at all from that side. You want to get the full voltage and current so that it can be applied to the load, being controlled by the voltage you are giving in. So the base here is to a jumper, so we can do that control over here and not clutter things. You may get away with not using the 10 kilo ohm resistor, and most of the time I haven't needed one. I did finally get a circuit where I did need one. I think it's if you're blocking enough voltage over here. But in any case, it's probably always better to have it, but you may see people omit it, and you can probably get away without using it in any given circuit. So first off, the trim pot, it's straightforward. One pin is to the positive rail. There's a resistive element through here. There you can see the resistor right there. And then the other pin goes to the negative rail. There's another pin in the middle there. That is where we will attach a jumper, or actually the oscilloscope right here. And look at the voltage. So it's set a little more than halfway towards the positive rail. So we are using 5 volts at the rail there. 5 volts right there. And you can see each square here is 1 volt. So 1, 2, 3, about 3.5 approximately. And so if we want to power this LED at about 3.5 volts, so the LED is here, long lead, the anode is up 1 row, short lead the cathode to this resistor. This resistor goes to the negative rail. And I can take this jumper and connect it directly. There you can see the LED. So the voltage dropped right there. That's the main takeaway. It couldn't hold that voltage, and we want it to, but it didn't. So now, the other option we have for getting an adjustable voltage is a light dependent resistor. So this one, the voltage depends on the light level right there. So we will take this, and based on the light level that we have right now, we'll see a voltage right there, and there it is. So of course I can actually the jumper was covering it, shading it a little. There we go. So there, that is the voltage. So I get a brighter light, the voltage goes down because this light dependent resistor is to the negative rail. So very, very low resistance made, practically a direct connection right there. Now there's higher resistance, some of the connections there, some of the connections there. We have a fraction of the voltage there. I turn it off and cover it with my finger. We're getting about maybe up to the millions of ohms right there. So you can see 1, 2, 3, 4, 5 squares for 5 volts right there. So in any case, we will get a certain amount of light on there, and I'll take this jumper again, and I'm going to block the light here and there so it'll change, but there we go. Now we have the light from the power supply and from the overhead lamp. There we hit the button and you can see the voltage dropped a little bit. So that wasn't too bad because we're not dealing with much voltage right now. Let's turn the lamp off. There we go. We have a lot more voltage to deal with, and trying not to block what you can see. There we go. Now you can see when I lit the LED up, we had a big voltage drop. So it can't hold the voltage very good with a load powered directly to it. Now our third option is the Zener diode right here. And so the Zener diode, you set the Zener voltage. The voltage that you want, you grab the particular Zener diode with that voltage and you put it in reverse bias. That's the main thing. So voltage builds up. Once it gets to the Zener voltage, it passes through the Zener diode and it holds that voltage. So it may be a little bit lower at lower currents, and so you need to make sure you don't use too much resistance to the positive rail. It has to be able to power whatever you're going to and to hold the Zener voltage. So now, just like the other ones, we will look at the Zener diode. So it is a 3.3 volt Zener diode. This is a 510 ohm resistor. And before we do this, actually, I'll shift this over. We'll just look at the voltage. So it's not attached to a load anymore. It's just on a blank row on the board. And there you can see the voltage. It's about 1, 2, 3, and about 0.3 volts approximately. Now we will light the LED. And you can see we got a drop right there. So it didn't hold the voltage as much as we would like. So we're going to grab a transistor, make an emitter follower, and improve all of these. And to begin with, we're going to take the trim pot. So the transistor here, the emitter down there to that resistor, we're going to attach a load. So we have the resistor before the LED, but order does not matter. They're in series, and the LED does not jump across rows near as well. So we're going to put the long lead, the anode, towards the emitter there, short lead the cathode down one row, and we're going to take a 220 ohm resistor, the one we were using before, because we're only going to put 5 volts across this LED throughout the video. So we're going to the cathode of the LED and then to the negative rail right there. And we will take a look at the voltage that we have the trim pot set to right now, and move the light so there's not glare. That's the voltage we got, about 1, 2, 3.5 approximately. And now we're going to go and put the jumper there and then to the base of the transistor. And you can see the LED lit up. The voltage did not change. That's the main takeaway. Now unfortunately we did lose, we're going to the emitter right there. We can see the, actually we need, I moved the wrong jumper. There we go. We got that jumper there, the oscilloscope jumper. I'm going to go to the emitter right there. So there you can see we did lose about 0.6 volts. That first line there, that's the voltage we're giving to the base, and then that is what the load is getting. So of course there is the base to emitter drop right there. But otherwise, you take whatever voltage you set here, it's going to be about 0.6 less to the LED, but it's going to hold steady. That is the main thing right there. We have the voltage set to about 3.5. whether we are powering the load through the transistor or not. That is the main takeaway. So now, the light dependent resistor version, same thing. So we're going to use a jumper to go to the base coming up. But again, we're going to use the same setup right here. The signal, though, will be coming from this point right there. And we take the oscilloscope there and we measure that point right there. That is the voltage that we have, as long as I don't block the light at all. And I'm going to block it for a bit while I add this jumper right there. There we go. So I got that jumper. Now we have that level, light level there. If I attach it to the transistor, we don't have enough voltage right now to get that to light up. So let's turn that lamp down. Let's turn it off right there. There we go. Now we'll have enough. And so now it's not powering anything. Just the oscilloscope is looking at the voltage. And when we power this, again, you can see that the voltage held steady. So we're dealing with 1, 2, 3, 4, about 4.2 probably right there. So once we drop about 0.6, we're going to have about 3.5 approximately volts. So that should be what is across the LED. So I'm going to pull that jumper, go right to the emitter right there, and there you can see we lost about 1/2 of a volt right there. And so we have a reliable representation. That's right, it goes up a little bit when it gets darker. We will raise the voltage and or the light, and there you can see we have that voltage there, but at the base about 0.6 volts higher right there. So that's transferring really well. It's not throwing it off. We're dealing with a lot of resistance here in relationship to the LED, but to power an LED, but it doesn't matter anymore. As long as we have enough to pass the voltage from the base to emitter and the LED, it will light up, and the power supply will provide the power. And now finally we have the Zener. So we're going to do something slightly different with the Zener. Now the Zener is not a percentage of the power supply voltage like the other resistance based ones. Its voltage is based on the Zener voltage of the Zener diode you're using. So we're going to go up to 9 volts right there. And we're going to keep a 220 ohm resistor to the LED because this is a 3.3 volt Zener diode and this is a 5.1 volt Zener diode right there. And so we'll never have more than 5 volts across the resistor and the LED. Now we're going to modify this. So here is the basic setup, if you didn't see it really well before. The resistor to the positive rail right there, coming to the Zener diode. So this is a 510 ohm resistor, and that's probably about as low as you want to go right now with 9 volts. So we should probably keep that. So that's going to the Zener diode. As you can see here, we have a rectifier diode there. That's because when it comes to blocking voltage, the voltages just simply add up. So I'm going to go down one row right there, and I'm going to take a rectifier diode right here. So it has a gray stripe. Not sure where it'll show up the best, but that gray stripe over there, that is the cathode. And so we're going to forward bias that. So the voltages will add up. We had a diode drop right there. We're going to give a diode raise here. So it's going to block this voltage plus the voltage of a forward bias diode. So we're adding 0.6 volts approximately to the signal, and the transistor, as we saw before, takes away about 0.6 volts. So pretty nice. And so our jumper will go there. We will take the oscilloscope here. So we will first look at the voltage. I mean, we can look at it here. We have the same thing where we have, I'm off a row right there. There we go. We have, as I said before, the 3.3 basically plus about 0.6. So a little more than 4 volts. 1, 2, 3, 4 at that point, because those two voltages are adding up that it's dropping. So I'll go here, and when I go to the transistor, the voltage there did not change. That is to be expected. So now let's go across the LED and the resistor, which is also where the emitter is. And there you can see we have that 3.3 volts basically of the Zener diode. And so looks like we got a little bit more, but it's close enough. It's below 4. And now I'm going to yank this, and oh, that's because there's nothing going on the negative rail. We do have 9 volts right now. That was a bad idea. So I'm going to pluck this. We were getting the direct 9 volts from the rail. That was passing along to that LED and the resistor. This is only a 220 ohm resistor, so we were definitely passing too much current through that LED. We can get an idea how much. We'll come over here. I have the power supply set to limit 30 milliamps of current. And off one row again. It's a little hard to see. There you can see we're up to 30 milliamps of current. So the power supply was helping to protect it. And what we can do is hit not that button, that button. So yeah, drop the voltage down as needed to keep 30 milliamps of current for the power supply providing. So just thought I would show that, but the main takeaway was we should have been more careful. Now I'll put, I think this is the 5.1 volt Zener diode, reverse bias, and we can look at the voltage at that point. 1, 2, 3, 4, 5, 6 volts. Oh yeah, that's right. We added the diode there. If we bypass that diode, it's about 5.1 right there. But we added some. I almost forgot about that. So now, that's not powering the transistor right now. We will power the transistor. There you go. You can see the voltage held steady while we did that. And we will pluck this now and look at the voltage across the LED and the resistor there. So 1, 2, 3, 4, 5, and a little bit more. That's what we expected. It's a 5.1 volt Zener diode. So there we go. So in any case, main takeaway, we give a weak signal. Luckily with the Zener diode, it's easy to offset that base to emitter voltage drop by just using another semiconductor. Their voltages that they're blocking will just add up as long as they're in series. Unfortunately, the resistor based ones are a little more complicated. You just have to set the voltage 0.6 volts above what you want the load to get. The main takeaway though is you don't need really any current from your signal there. You just basically set up a voltage as far as the transistor is concerned, and it allows whatever current through it that it needs to hold that voltage across the load. It works out really nicely. So this isn't the best option a lot of times, but it's a simple one. And so anyways, hope you enjoyed the video. Thanks for watching. I will see you in the next video.